unsorted linked list. Giving the head of a linked list, find all the values that appear more than once in the list and delete the nodes that have any of those values. And we should return the linked list after. So what we have here is a linked list that we have, and it says if there is a duplicate value like number 2 here, we have 2 of these, we are going to remove both of them, and then we are going to return the linked list. So as you see here, we have 1 2 3 2. So what we're going to do, we are going to remove the both node 2, and we are going to return linked list like this one, 1 and 3. In the other example, as you see, we have 2 1 1 2, and we have 2 of each, so we have to remove 2 and 1s, so we are going to return an empty linked list. And in this example, as you see, we have these numbers, and after removing the duplicates, what we are going to have is just 1 and 4 node. And the constraint here, it says like we are going to have at least like the number of nodes in the list start from range 1 to 10 power 5, so we are not going to have an empty list, and the values are going to be from 1 to 10. So as you see here, when we create a linked list, when we create a node, the default value is 0, which is not included in this range. So using all this information, what we are going to do, if you want to do it in one path, so we need to create a dictionary, a hash map of the values that we have in the linked list. So when we are doing one pass, when we see that value, we know we have it in the dictionary, and we check how many of these values that we have. And if it is more than one, we are going to remove that when we see it. So let's see how we can do that. For doing this, we are going to use default dictionary from collections. So we are going to call collections library, and we are going to call default dict, and we are going to consider that as integer values, right? So this is the hash map that we are going to have. And then what we're going to do, we are going to put the head somewhere called current, and you're going to say while current, what we are going to do, we are going to say for the value that we have, the hash map, because we are using this default dictionary, we don't need to check if we have that value in the dictionary or we don't. It doesn't matter. So we are going to say hash map for the current. We are going to get the value. As you see here, when we create a node, we are going to have two things. We are going to have value and next. We are going to say for the value, and we're going to plus equal 1, and we are going to move one step forward. Oh, sorry, current dot next. We go to the next value. So what is happening here? So we start from, like in this example, we start from number 3. We check that if it is not in the dictionary, we are going to add it, and we are going to assign 1 to it, and then the same thing happens. So let's print this hash map so you can see it better. Okay, as you see, let me use a bigger example here. So let's change the test case to this, and let's run it. So as you see here, this is the dictionary that we are going to get for this example. So I'm going to just put it here for like illustration purpose, for understanding this. So this is what is happening here. So this is the dictionary. We have 2 3, we have 3 number 2, we have 1 node 1, and we have 1 node 4, right? And now then what we're going to do, we are going to start iterating over this linked list again, and we check the value. If we have them in the dictionary, we are going to remove them right away, and if we don't, we're just going to pass them. For doing that, what we need to do, we need to for removing a value, a node, we need to know what node we have before that. And for making this like solution easier, we are going to use a dummy node here. So I'm going to create a node, list node, and I'm going to put like create a node, and as you see here, all I need to do is I'm going to put 0 here, and it's going to put just this here. Next is equal to head, because the default value for val is 0, so we don't need to define that. And then what I'm going to do, I'm going to say the previous pointer is pointing at dummy variable, dummy node, and the current one is pointing at head. So then we are going to have a while loop. We are going to say for while current, as long as the node is not empty and we are not pointing at none, we are going to say if hash map of the current dot val is bigger than 1, we need to do something. We need to remove that node. We are going to say current is equal current dot next, and the previous one dot next is going to point to current. And if the value that we have, the value that we have for that key is not bigger than 1, what we are going to do, we are going to just go one step forward. We are going to move the current pointer one step forward, and we are going to move previous pointer one step forward. And at the end, what we're going to do, because we have a dummy variable here, we are going to return dummy dot next, because we don't want the dummy node to be included. And run this, and there you go. The time complexity for this is going to be linear, and the space complexity is going to be linear as well, because we are using this dictionary. Thank you.